Catalysts are a critical part of all industrial processes and are used to improve the reaction rates, yield, and overall economics of these processes. Many common industrial catalysts require elevated temperatures and pressures and are rare or precious metals that are expensive and environmentally toxic.
Biological catalysis utilizes microorganisms or enzymes to catalyze reactions. These catalysts proceed with high specificity, work at ambient temperatures and pressures, are regenerative, and are non-toxic.
Enzymes are already used today in a variety of manufacturing processes, including textiles, pulp and paper, detergents, and pharmaceuticals. Microorganisms are being explored for use in microbial fuel cells and for both organic and inorganic nanoparticle biosynthesis.
Enzymatic catalysis is more environmentally friendly than traditional metal catalysis, as it reduces energy consumption, fossil fuel feedstock requirements, and carbon waste. Biological catalysts can also operate at a smaller scale, leading to enhanced economics and more rapid technological advancement.
As there are only a small number of enzyme classes commercially used today, further development in catalyst engineering and production scale-up is necessary to ensure reproducibility and predictability of the processes, enhance chemical conversion, and expand the technology with novel discoveries for potential applications in other fields.